That means that my equation for AP reads y is equal to 1 over 2x plus c. Substitute any point that I have. I'm going to substitute that point in. That means that negative 1 is equal to a half times negative 4, which is negative 2, plus c. C is equal to negative 1 plus 2, which is equal to positive 1. That means that our equation reads y is equal to a half x plus 1. Let's just write that somewhere in there. A half x plus 1. Now the reason I had to start by getting the coordinates of P was that I didn't have any more information. In order to get the straight line, remember, I need either 2 coordinates or I need a gradient and 1 set of coordinates. In this case, I had neither. Let's just put in the coordinates of P. That was 7 plus, that was 6, and that was 4. Right, that's the coordinates of P. So I first had to get the coordinates of P, and then I used that to get first the gradient of AP and then the equation of AP. Number 2, the length of AP. That we're going to use the distance formula. AP is going to equal square root of y2 minus y1 squared plus x2 minus x1 squared plus, because that was negative and negative, is equal to square root of 4 plus 1 is 5 squared is 25, 6 plus 4 is 10 squared is 100. That means that AP is equal to square root of 125. Now 125 is the same as 25 times 5. Square root of 25 is equal to 5. Square root of 5 we can't find. That means that AP in simplest third form is equal to 5 root 5. The next thing I asked you was, is AP a height? Now if AP is a height, it means that the gradient of AP would be the perpendicular gradient or the negative opposite gradient of BC. The gradient of BC is equal to y2 minus y1, 3 minus 5 is negative 2, over x2 minus x1, 7 minus 5 is 2, which is equal to negative 2 over 2, which is negative 1. And the gradient of AP we know is equal to positive a half. Problem: these two are not the opposite gradients of each other, because negative 1 multiplied by 1 over 2 is going to give me negative 1 over 2, which is not equal to negative 1. If these two were perpendicular, the product of their two gradients would have to be negative 1. In this case, it's not. That means that AP is not a height. The second one I gave you to do looked something like this, with points A, B, and C. Coordinates of B and C are given. I then said that AB is equal to AC, or rather, if AB is equal to AC, find the equation of AD. Quite an easy one to do. To get the equation of AD, I need either a gradient in one set of coordinates or two sets of coordinates. I can't find the coordinates of D, not yet at least. But I can find the coordinates of A, and the way I'm going to do that is by saying AB is equal to AC. A, I'm just going to give it the coordinates x, y for now. That means that AB will equal y2 minus y1, which is just going to be y plus 1 squared, plus x2 minus x1, which is x minus 3 squared, that's AB, is equal to y plus 1 squared plus x plus 1 squared. All I've done there is said that AB squared is equal to AC squared. Y plus 1 squared on both sides are going to cancel each other out. That means that x minus 3 squared is equal to x plus 1 squared. That means that x squared minus 6x plus 9 is equal to x squared plus 2x plus 1. X squareds on both sides cancel. Minus 6x minus 2x is minus 8x is equal to 1 minus 9, which is minus 8. That means that x is equal to negative 8 divided by negative 8, which is positive 1. X is equal to positive 1. Now the question is, what is the y value? Remember, I said that AD is a height. So, if AD is a height, wouldn't the gradient of CB be perpendicular to the negative opposite of the gradient of AD? The gradient M of CB is equal to y2 minus y1, which is going to give me negative 1 minus minus 1, or negative 1 plus 1, which is 0, over 3 minus minus 1, or 3 plus 1, which is 4. So my gradient is 0. That means that my opposite gradient is undefined. That doesn't mean we can't get the equation of AD. All it means is that AD is a perpendicular line, perpendicular to the x-axis, or rather parallel to the y-axis. That means that I drew my graph a bit wrong. It should rather look like that, and it's perpendicular there because I found that my gradient is undefined of AD. That means that the equation of D, now look at that. We know that the x value at D is 1. That means that the equation of AD is the equation x is equal to 1. That's all that the equation of AD is. Now, the second thing I asked you, is AD a median as well? In order for AD to be a median, D would have to be the midpoint of BC. Is it? The midpoint of BC is going to be given by 3 plus negative 1, which is 2, divided by 1, which is equal to 2 divided by 2, which is equal to 1. So it seems as though the x value is definitely going to make it a median. In terms of the y values, we're going to get a y value of negative 1 plus negative 1, which is 0, divided by 2 is 0. That means that the midpoint, that's negative 1 plus negative 1. That means that that's going to be negative 2 over 2, which is negative 1. Now we don't have the y coordinate of D, and we haven't been able to calculate it, but based on the x value, D is the median as well as the height. And that brings us to the end of the third tutorial on analytical geometry. It was an easy one. I hope you had fun. Please go through the exercise that I left for you in the workbook before progressing on with the next tutorial, titled Cumulative Basics.